So today we're going to be focusing our attention on dividing by a monomial. Remember that a monomial is a polynomial that only has one term. Now, in order to see how we're going to do these problems, I want to go back to things that we talked about earlier in the semester. If I was adding a fraction like 1/5 to a fraction 3/5, remember that we would add the numerators and then simply bring forward that common denominator of 5. So we would have 1 plus 3 in the numerator and 5 in the denominator. Now, early in the semester, then, we would do 1 plus 3 being 4, and our final answer would have been 4/5. Now, today, what I want to focus on is just these first two pieces. But instead of traveling left to right, I want to travel right to left. So what I'm seeing here, then, is that if I have one big fraction, and that numerator involves addition, and we have one term in the denominator, I can break that big fraction into two smaller fractions. So let's use that idea in example 1. The directions for example 1, divide, and we have a binomial in the numerator and a monomial in the denominator. This technique that I was talking about here only works if our denominator is a monomial. So I'm going to take my big fraction, like this 1 plus 3 over 5, and break it into two smaller fractions. So the first term in my numerator, negative 6x, is going to be divided by my denominator of 2. Then we have plus second term in my numerator divided by my common denominator of 2 as well. Now, why is it useful then to take the big fraction and break it into two smaller fractions? Well, it's possible that some of those smaller fractions then are things that we're going to be able to simplify. So as you look at negative 6x divided by 2, notice the 6 and the 2 both share a factor of 2. So if I cancel that 2 out of the 2, I'm down to 1. Cancel the 2 out of the 6, I'm down to 3. And then I'll do the same thing with 4 divided by 2. Cancel the 2 out of the 2, we're down to a 1. Cancel the 2 out of the 4, we're down to 2. So let's see what's left over. We have negative 3x divided by 1. Well, divided by 1 doesn't really do anything for me, so it's just negative 3x. And then, the second piece, we have plus 2 divided by 1. Again, the 1 really doesn't do much for us, so we can just write that as plus 2. Now, at this point, then, we've done exactly what they requested. They asked us to divide these two polynomials, negative 6x plus 4 and 2, and we ended up then with the answer, negative 3x plus 2. Well, now that we have that idea, let's go ahead and try part B. So in part B, again, I have a two-termed polynomial, a binomial in the numerator, and a one-termed polynomial in the denominator, a monomial. So I can play the same game. I'll take my numerator and break it up. First term in the numerator, 5x, divided by that common denominator of 3, minus 6, the second term in the numerator, divided by that common denominator of 3. This time, however, I'm not going to be able to simplify both of these fractions. So when you can simplify, you simplify. When you can't, you don't. So here we have 5x divided by 3. 5 and 3 don't share a common factor, more exciting than 1, so I'm not going to be able to do any kind of reducing there. So this is 5x divided by 3, which is a fine way of writing it. However, just to make the point that since we're in the land of polynomials, I want to say that I can change this, and instead of writing it as 5x divided by 3, I can write it as 5 divided by 3, and then put the x next door to that. So you want to make sure that you're comfortable with the fact that both of those are really saying the same thing. And if you need to, you can always think about this x and say, oh, that's really x over 1. And once you realize that that's x over 1, multiplying fractions, you would have 5 over 3 times x over 1, multiply numerator times numerator, denominator times denominator, and we would get exactly the same thing here. So I have 5/3 x, and then let's see what happens with the next piece, 6 divided by 3. Well, that one is one that I can do some reducing in. So 6 and 3 both share a factor of 3, so that cancels down to a negative 2. So the polynomial answer is then 5/3 x minus 2.